All right, guys, welcome to another episode of Cuda Education. We are on the pipelines.cpp algorithm. First of all, I want to thank Sascha Willems for this wonderful algorithm that we're using to learn the Vulkan API. If you want to join in on the fun and be able to run these examples, you need to get tutorial number 1 and tutorial number 13. I have links down below. I also have the tutorial series down below, so you could check that out in the links. Kind of want to get into this really quick. Um, it's a little bit intricate and a little bit involved, so you really have to pay attention on this one. Just so you guys know, this is the what the algorithm does. It basically shows 3 separate pipelines, one in this kind of display, one in a hyper color display, and one in a hyper wireframe display. Okay, so this is the basically the gist of the algorithm, right? That's what the script achieves. Again, if you want to get this running on your Windows-based machine with a Vulkan capable GPU, you need to get tutorial number 1 and tutorial number 13. All right. So this, I think, is the second video in the pipelines.cpp algorithm series, and this particular function that we're going to focus on is the preparePipelines function. Okay. I might have to do multiple videos on this particular function because it's sort of involved. We could kind of look at the definition of the preparePipelines function. Basically, it is preparing the pipelines, right? So it's outlining a bunch of options that we need in order to get our pipeline going. Now, for the options that I kind of are obvious, or I was able to explain, I've kind of already gone through it in the previous series, the Gears.cpp series, where I kind of went through, topology, polygon mode, which was part of this rasterization, the cull mode, front facing and back facing, clockwise, all of that stuff, right? I didn't get into the blend, depth stencil, didn't really get into viewport state, multi-state, dynamic state, and all that, right? But as far as these first couple ones, yes, I got into them because I'm familiar with them and it's easy to kind of tinker with them and see a result on the screen. So, if you definitely want to get a deep dive into these options here, at least, definitely check out the Gears.cpp series. I go into that where I change options and then you see the output on the visual screen, which is a bunch of gears turning. Okay. But that's not what I want to focus on. These, once I learn more and get work with more of the examples and learn more about, what happens when these changes, I'll certainly make videos and content on these things, right? But anyway, we have a bunch of initialization helper functions that help us to sort of outline the options for the pipeline that we're building, right? The graphics pipeline is basically, the way I look at it is it's a logical line of resources, events, and just items that are put together in order to eventually present graphics to the screen. That's my layman terms definition of a graphics pipeline. I kind of think it's a very abstract concept, but as I'm working with these examples, I'm learning, exactly what it is in a more tangible and concrete way. Okay. So we're basically outlining a bunch of options here about what we want in our pipeline. And then, this down here is just basically, rehashing all these variables here and putting them, associating with this pipeline CI variable. Okay. So that's pretty clear cut and obvious. One thing that I want you to pay attention to, though, is that with this VK graphics pipeline create info pipeline CI, notice that we're initializing it with pipeline layout and render pass, right? And this is something that it really brought attention to sort of, you know, what we've been working on, this pipeline layout variable and render pass variable. I'll get back to these in a minute, but just understand that to create this pipeline CI variable, we had to use these pipeline layout and render pass. Very important, these variables, right? To sort of initialize the pipeline CI variable. And then, of course, we just encapsulate all the work that's up here into these variables here, and we associate them with the pipeline CI variable. Okay. We have vertex input state. That's probably something I'll get into at another time, but I have made videos on vertex input state and all that stuff. But I'll probably get into that in another video. I don't want to focus on this right now. All right. So we're continuing to go through the prepare pipelines function. Create graphics pipeline state object. We're using this pipeline as a base for the other pipelines, derivatives. Pipeline derivatives can be used for pipelines that share most of their state. Depending on the implementation, this may result in better performance for pipeline switching and faster creation time. All right, so this flag right here, pipeline CI flags, VK pipeline create allow derivatives bit. The way I see it in layman terms is that basically you wanna instead of recreating every pipeline from scratch, you just want to basically share resources of or rehash the same pipeline that was already initiated and created and just tinker with a couple of things to create new pipelines. If when we ran the algorithm, you saw that there were 3 distinct pictures, right? 3 distinct scenes, right? With slight modifications. That's the idea, is that for those 3 distinct scenes with which is a rehash of generally the same thing, but just with slight modifications, you don't necessarily want to create each pipeline individually separate from each other. You want to create a baseline pipeline and then make modifications on that baseline to generate the other presentations or graphics or what have you. That's the way I see it, and I think that's what this flag does. Okay. Now a quick side note is that I have I've tried to tinker with, for example, this flag to like either not use the flag or change the flag to something else so that you wouldn't allow derivatives. But unfortunately, when I do that, the script still kind of runs and it still kind of does what it would do with the correct information. So, I was a little bit, I was hoping that if we made certain modifications, like, not have this flag, that the script would either crash or it would just not generate the other pipelines, or something like tangible and obvious would happen that would say, okay, because the script is now not working because this flag is off or it's wrong or it's assuming something that hasn't been checked off as an option. But unfortunately, when I tinker with this flag, it still runs and does what it's doing. So that's just a little bit. But yeah, that's what this flag is basically. We're using this pipeline as a base for the other pipelines. So it's an efficiency thing, right? Obviously, in programming and stuff, we always want stuff to be efficient. Textured pipeline. These are the the SPV files that we're using to generate the presentation. So we have our vertex information and we have our color information here. And then we VK create graphics pipeline. And we are putting in all of our information. Let me just continue. I don't want to dive into this right now exactly. All pipelines created after the base pipeline will be derivatives. So here we set another flag, VK pipeline create derivative bit. Okay, so we have a flag here and a flag here. Somehow, one is distinct from the other, but Right. All pipelines created are after the base pipeline will be derivatives. Base pipeline will be our first pipeline. So the first pipeline on the left was was the base pipeline. It was three different scenes, and the one on the left is the base pipeline. It is only allowed to either use a handler index for the base pipeline. As we use the handler, we must set the index to -1. See section 9.5 of the specification. Okay, so I guess we're using the handle pipelines.fong, and we are not using the index. So the index is set to -1. I think with this also, I tried to set the index to something else and see if the algorithm would crash or do something strange or whatever, but it didn't. The algorithm seems to be very resilient, right? And regardless of, whenever I try to play around with the functions, it would still run and do its thing. So in that respect, I think I tried to play with this, and it still would run. Like I'd set it to a positive number, or a large negative number, and it would still run, right? But don't quote me on that. So we have the fung assets here, vertex and color information. We have the tune assets here, vertex and color information. And notice that we're creating another pipeline here, but I assume now, because this flag is set, derivative, right, that it basically said it uses the same assets here, from the first pipeline created. Tried playing around with this too. It still ran. It still showed the pipelines, what have you. I tried, I think, commenting it out or something. It still did its thing. Okay. So we have our tune pipeline now, which was the middle one. And then we do it all over again. The only thing is that here we check for a specific feature of the we check the specific feature of the Vulkan implementation, and I assume too, maybe perhaps GPU capabilities, but we have this device features function that basically checks, do you have the ability to display wireframes, right? Between Vulkan and I assume maybe the GPU, we check for that. So if device features .fill mode, non-solid, if it is available, if this renders true, then we're able to also do the wireframe version. And you see you have the wireframe assets. You have the vertex and the color information, right? And then we create a pipeline here. All right. So that's pretty much the preparePipelines bit. Now, while we're here, I'll just kind of also mention that this pipeline cache piece, right? Pipeline cache. I've also tried to play around with this, removing it or putting like null pointer, or trying to just void this thing or do something else to see if it would affect what is rendered. Algorithm was still forgiving, still robust. It still rendered. I don't think it did anything strange. But if we look at the VK pipeline graphics definition, you have this VK pipeline cache type variable that it's expecting, right? And when I looked it up on the spec, it's like it's what you would, it's caching the pipeline thing, right? It's caching the pipeline creation, right? And notice that it's being passed along with all three VK create pipelines graphics functions. Okay, so I tried messing around with this, but it still ran. So I can't at this point in my journey, I can't really talk much about it. But just know that it's a thing. If I go to definition of the actual variable itself, pipeline cache object, okay, and this is in the example Vulkan example base. So it's like one of the header files, the base files for for all of the examples, but it's still there. And that's as much as I know right now. The Notice that the pipeline CI variable is ever present, and I think this is probably one of the most important pieces of this function call, is this pipeline CI. And it makes sense, right? Because we put a lot of work in here to build this pipeline CI variable. Okay, so this is what connects everything and makes the magic work. Every time, one of the things about learning Vulkan and what I'm particular about in programming is, it's one thing to like have functions here, there, and everywhere, but I want to see what is the link, what is the communication link, what torch or baton is being passed in order for the what key information is being passed along in order for the algorithm to work. Like if you did all this work here and then now you're creating the pipelines, but like there's no relation, variable or otherwise, between what's up here and what's down here, I'd be like, what's going on? Like, what does one have to do with the other? So I'm always paying attention to what is being passed along. All right. So just keep that concept in mind, right? So we do this work up here and then it's being passed along in all of the VK create graphics pipeline calls here. And whenever we see a lower VK function call, we have to pay special attention to it, because now you're actually doing something in Vulkan. Like you're really, really doing something in Vulkan. Like, it's a serious thing. These are like variable types and stuff, but when you see lowercase VK and then it's a function, it's like the Vulkan API itself, right? That's the way I like to think about it. So just to rehash, between the pipeline CI work that we do here, the pipeline VK pipeline create allow derivatives bit flag, and then the VK pipeline create derivative bit here. So we have VK pipeline create allow. Sorry. So let me start over again, because I'm just going like 100 miles an hour. Between the VK pipeline create allow derivatives bit, right, which is up here, this is like a high level flag, and we call this, or we set this before any of the pipelines are being created, right? Before the first VK create graphics pipelines is called, we set this flag. And then after the first pipeline call, now we set another flag. All pipelines created after the base pipeline will be derivatives, right? So the way I think about it is that, this is a general option that, when you're creating the first pipeline, you have this general option that says, hey, I'm going to allow derivative pipelines off of my pipeline, right? So this is called before any of the create graphics pipelines are being called. But then after the after the first one is being called, you say, hey, every pipeline that I create after this is going to be a derivative off of the base. And I'm going to assume that this is the base because it was called before this flag was set. That's just my logic. Don't quote me on it, but just looking at the algorithm, that's the line of reasoning that I'm gonna run with, right? That you have this general option, you run the first pipeline, and then now you say every pipeline after that is going to be a derivative, right? So, there you have it. So you still have our pipeline CI that's being used. We have different handles for all of the pipelines that are being created. So, if I wanted to refer to the Fong pipeline, this is the variable name that I would use, right? If I want to refer to the Tune pipeline, this is the variable name that I would use. If I want to refer to the wireframe pipeline, this is the variable name I would use, right? So that's the line of reasoning. Pipeline cache, we already kind of, I said what I said about that already. I don't really have much more to add. And then, VK create graphics pipelines, okay? So that's pretty much the prepare pipelines bit. I do want to go over one other quick thing. So uh initially I said that we're gonna do the prepare pipelines bit, right? For this video. The previous video was set up descriptor set layout, right? Now remember I said that I'm always about the golden thread of information, one being passed from the other. What information from this setup descriptor set layout function is being passed on to this prepare pipelines function? Okay, so let's go to the descriptor set function, right? I'm not going to go through it again because I did it in the previous video. But remember, anytime you see descriptor set, you're talking about memory management or memory objects or managing memory or telling Vulkan what it is you have in memory and who can access it or what's the conditions, the context, all that stuff. So real quick, we're dealing with uniform buffers. So that's what's in the descriptor set layout is a uniform buffer, and the vertex stage of the pipeline can access it, right? Already went through this before, not going to go through it again, okay? And then we kind of pass on that information. We do this lowercase vk create descriptor set layout, the descriptor set layout saying, hey, there's a uniform buffer, memory object, and only the vertex stage of the graphics pipeline can access it, okay? We do some other work. We're basically just passing on information again. But notice in the setup descriptor set layout, we create pipeline layout. So I always say that whenever we see descriptor set, whenever we see descriptor set layout, the final piece is always like handing it off to the pipeline somehow. So how does descriptor set layout relate to prepare pipelines? Well, we go back to our descriptor set layout. We see that here we have our VK create pipeline layout, and then we pass along all the information. This is just semantics, I think, for the most part. But we pass along all the information that we did up here, and then we put it into pipeline layout variable. Where do we see this pipeline layout variable? Well, remember, we're talking about this function here, and then we're going to prepare pipelines. Where do we see that? Where did we see that variable? We saw that variable here. Okay? So that is the golden thread of information that's being communicated from one function to the other. All right? So we're not just doing all this work for decoration. I mean, listen, it's amazing to hear me talk and all that stuff, but we're not doing it for decoration. We're actually trying to make some progress. So we do all this work to get it into this pipeline layout variable. Once we're in that pipeline layout variable, we drop it into this bad boy right here. All right? And then we do all the work and what have you. All of this basically gets encapsulated into each of the graphics pipeline creation. Okay? Each of the graphics pipeline creation. Okay? So that's the golden thread of information that we're passing along from one function to another. All right? Notice this is VK create graphics pipeline, which is different from VK create pipeline layout. So here is VK create pipeline layout, and here is VK create graphics pipelines. Okay, you could Google these things, because this is part of the Vulkan API now. You could Google it, look at the spec, and see what the nuances of each, how the spec describes it, what they're talking about. But here we're kind of just creating, we're building up to creating the graphics pipeline. We're setting things in motion or what have you. But this right here is the real deal Holyfield, okay? And if you don't know who Holyfield is, Google it. Okay, you need to know who Evander Holyfield is. Okay, um, you need to know who Evander Holyfield is. You need to know who Mike Tyson is. Google it. So right, you need to so that's the nuance between these two things, and that is how it's that's how it's all connected, right? And we check for we check for a device feature here in order to get to run this. Now obviously if this test fails, then we don't see the third rendering, right? We don't see the third piece of the puzzle. We don't see the wireframe rendering. Okay, so that's a whole topic for another day. Not going to get into that. There is one other thing though that surprised me that I kind of want to discuss. It is a little bit what's the word? It's a little bit forward facing because I haven't for this particular discussion I haven't we haven't for this particular season I haven't gone through it. So we did set up descriptor set layout. We're doing now prepare pipelines. Okay. Build command buffers is called later on in the discussion, right? So this is sort of the master file of order of operations. Startup, prepare, load assets, prepare uniform buffers, set up descriptor set layout, prepare pipelines, blah 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 blah. Okay. We haven't reached this part yet, but I do want to mention something very important. What I want to get into is this render pass variable, right? I didn't realize that the render pass stuff is already being dealt with, right? So if we go to definition for render pass, right? Global render pass variable for frame buffer rights, okay? VK render pass, okay? So in the previous series, we know that we build a command buffer, which is basically setting up a bunch of commands and running those commands, and within the command buffer you have your render pass, and the render pass is basically kind of what it suggests. You're rendering stuff to the screen. So you have your command buffer as a wrapper around the render pass, and that makes sense here, right? We discussed this in the previous script, gears.cpp. We have our render pass, begin render pass. We have our command buffer, begin command buffer, end command buffer, and within the command buffer situation, we have begin render pass, right? Notice it's after we call the command begin command buffer, and we have our end render pass, right? And the render pass is really what we actually do the process information and all that stuff. I'm not going to get into it in this video, but I do want to mention though that the render pass variable, okay, the render pass variable is being associated. We obviously we discuss it here, but this build command buffer is like one of the last functions to be called, but we're already using it or making preparations for it in the prepare pipelines discussion, and it was kind of surprising to me. So this create pipeline info situation, VK create graphics pipeline create info, right? So we have a layout, which we discussed already, and then we have this render pass variable. And basically we are, we're associating the render pass object with the pipeline here. Okay, so we're associating the render pass object with the pipeline here, right? Which was a little surprising because I never really I never really thought of how does the render pass interface directly with the pipeline. Now I understand how it relates to the command buffer, but how does it relate directly to the graphics pipeline? So we are associating the render pass with the pipeline, right? And that's as far as I will say. But it was a very curious thing. Now I understand why the pipeline layout variable is associated with all this stuff, because obviously with the descriptor set layout and stuff, I get that. But then the render pass variable is being mentioned here. Okay, so so that's how the render pass is being associated with the pipeline. I don't remember in gears.cpp if we had a similar situation between the gears and between the render pass and the pipeline, but it was just kind of interesting to see that it is part of the situation. Also, I kind of find it funny that like the render pass is sort of in this call here. It's in this call here where the VK graphics pipeline create info. It's sort of here, and in this sort of situation, and not necessarily one of these or one of these, right? But that's above my pay grade to really discuss right now. And then we just continue. And now we're kind of seeing how a pipeline is, we're kind of seeing in a real sense what the graphics pipeline is and what it's sort of in charge of, what it's doing. It's still sort of, generally speaking, an abstract thing, but when we sort of run the code and we sort of work through everything, we see what's happening in a real way. So let's just run it again. So we see our we see the 3 pipelines: 1 pipeline, 2 pipeline, 3 pipeline. Okay, and that's what it is, right? We see all the things below, what have you. All right, and we see like the tree and everything. Okay, cool. Remember, I keep saying that these VK calls are very important. So let's just comment out this one line. Okay, so we're commenting out just that one line. And it doesn't run. I thought it would run, actually. My bad. Let us do. What am I doing? Okay. All right. Still doesn't run. Okay. Could have sworn that. Well, is it still? All right. I tried to play hero, but it didn't work. Interesting. Yeah. So one other thing I wanted to discuss was, remember how we kept saying that as it relates to pipelines, okay, this is still somewhat related to pipeline, so I have justification in getting into it, right? We go back to our descriptor set pipeline, descriptor set layout, set up descriptor set layout, right? Notice that we tell the pipeline, or we tell Vulkan, hey, this, this piece of memory is a uniform buffer and only the vertex stage can access it, right? Let us change this to compute. So now we're saying only the compute stage of the pipeline can access it, right? What do you think is going to happen? So now the vertex stage doesn't have access to this uniform buffer object because it we explicitly told the pipeline, hey, VK create pipeline. We explicitly told the pipeline only the compute piece of the pipeline could access it, right? So if we run this thing, you're going to see that it crashes, right? And that makes sense because only the compute stage can access it, not the vertex. So of course the vertex stage wouldn't have the information and blah blah blah, and the whole thing goes to hell. So that's part of the whole discussion with the pipeline. I also wanted to just really quick go through the just where render pass is being called, right? So if we do render pass, this is part of the build command buffer function. So all of these things are not this is being called after everything, but the earliest, I believe, the earliest call to render pass is in the preparePipelines function, which is here. Okay. So and then of course we could go to definition for render pass, and we saw that already. All right. So that's pretty much it for the pipelines. But I think this makes it more tangible for everyone to really understand, the amount of work that has to go into creating a pipeline. Now, again, the big knock with Vulkan is that it's a lot of lines of code, a lot of it's a lot of work and stuff. And yes, in terms of typing, yes, it's true. But think about how powerful, if you're a creative or if you're someone that's you want maximum control, whether it is because you want better performance or whether it is because you want more control over the artistic presentation, the graphics presentation or something, right? Look at all of these options as opportunity. Okay, an opportunity to craft something exactly the way you want. In OpenGL, a lot of these things you wouldn't have the opportunity to change or to update or to do different things because everything is kind of done for you over a master function. But if you have these options here in the Vulkan API, then you have more control over your destiny. Of course, yeah, it is more work and more things can theoretically go wrong and stuff, but just appreciate the amount of power that you have. And of course it is a little bit more challenging to learn because like half of this stuff I still don't fully understand or appreciate what they're for, but it's a step in the right direction. So that's pretty much it I have for pipeline. We're calling, man, I'm kind of disappointed though. I was hoping is it because I'm not rebuilding? Is that what it is? Maybe because yeah, so nope, nothing. Anyway, guys, I'm not gonna spend any more time on this. Please like and subscribe. Tell your friends about this video and all the videos and the Cuda Education series. Get you and a group of your friends together. This is part of being a leader. Get a group of your friends together and say, hey guys, let's figure out this Vulkan API stuff. Because we could build video games. That's how you sell it to them. We could build video games ourselves and we could build cool graphics ourselves, right? Get a group of your friends. You spend a lot of time. If you spend a lot of time playing video games, deposit a couple coins in the bucket of learning something for yourself. Anything you learn in life, it will help you in the future. So, um, yeah, just spend the time. I'm here. We're all here. If you look at the comments, you'll see that a lot of people find these videos helpful. So I'm sure you guys can figure it out. Tutorial number 1 and tutorial number 13. Get the Vulkan examples installed and running on your Windows-based machine with a Vulkan-capable GPU. I assume no programming experience whatsoever. So, don't think I'm some, programming genius that I'm just gonna reel off a bunch of terms and concepts and constructs and stuff and lose you in the process. I am very straightforward. It's just a screen and a mouse, and I work through everything that needs to be worked through in order um to get these examples running on your computer. Once you have the examples running on the computer, then it's game on, because now you can tinker with the code. You could, read the spec, read the Vulkan spec. I think they did as best a job as could possibly be done for the amount of things that they have to communicate and the nuances of things that they have to impart to people. So I think the spec is very good. It's just that it's a lot of information, a lot of nuanced stuff. So um, whether you want to watch my videos or you want to just work through the spec yourself and play around with the different examples and get it get it working for yourself and see what breaks, see what works, see what displays differently, whatever you want to do. But it's time well spent, guys. It's time well spent. Learn something. Make it a commitment to yourself. It's more fun if you have friends that you're all working together. If you're artistically inclined, if you like, cinema, if you like CGI, if you like animation, cartoons, if you like augmented reality, all of that stuff. If you like, even if you're in business and you're rendering real estate, you're rendering, a future skyscraper. If you're in architecture, if you're in business and you just want to, render certain things that relate to the business process, there are a million different things that you could do if you have the art or understand the art of graphics rendering. You understand? So something that you could put on your resume. It's something, you would be good as gold, right? And people will pay you a lot of money for it. But it is it is involved. It's a cottage industry. It's yeah, it's not everybody that's just gonna dive into this stuff. But I encourage you, if you're watching this video, that you should do it. All right. Anyway, that's my pep talk for all of you guys. Thank you for watching. Like, subscribe, and I guess you got to ring the bell too. Tell everyone, support the channel. Tutorial number 1, tutorial number 13. Get the examples running on your machine, and let's go for 2024. All right, guys. Have a good